So the first chapter we have completed from the arrangement of elements to the periodic properties like atomic size, ionization energy, electron affinity, and then electronegativity. And we have also seen the various factors determining ionization energy, electron affinity, and electronegativity. And also we have seen the applications of electronegativity measurements. So these are all the things we have seen so far. Now we are getting into the second chapter called chemical bonding. This is another very important and interesting chemical idea. Why two atoms are together? What is making the two atoms combine and to exist in the form of a molecule? It is a wonderful question with a beautiful answer. What tendency is making the atoms combine to exist in the form of molecule in nature? So atoms normally they do not have free existence in the atomic form except the noble gases, because the noble gases have completed electronic configurations, therefore they need not give or accept electrons from any other species to form a stable electronic configuration. Hence all the noble gases exist as atomic molecules. Atomic molecules means the atom itself functioning as a molecule or the substance which are stable in their atomic form itself. They are the noble gases. But the attractive force which holds together the constituting atoms within a molecule is called a chemical bond. The other atoms cannot exist in free state in nature, so they are all found in a combined state. Sometimes they are combined with themselves, and sometimes they are combined with the elements of others or the atoms of the other elements. But whether it is of the same kind or of the different kind, the attractive force which hold them together is called the chemical bond. So chemical bonding, say for example, hydrogen exists as a hydrogen molecule, H2. The attractive force between two hydrogen atoms is a chemical bond. Similarly, oxygen exists as O2, oxygen molecule. The attractive force between the oxygen atoms is also called chemical bond. Suppose I say nitrogen dioxide. The attractive force between nitrogen and the two oxygens is also chemical bond. Hydrogen chloride. The attractive force between hydrogen and the chlorine is also chemical bond. But hydrogen cannot exist in the atomic form, and the chlorine also cannot exist in the atomic form. But hydrogen and the chlorine can combine and can exist in the form of a molecule, and they are all very stable molecules. So the attractive force between two atoms, whether they are of the same kind or of different elements, that's not material, that doesn't matter. The attractive force, which are the force which is holding together the constituent atoms within a molecule, is called a chemical bond. So the chemical bond is actually the force which is holding the atoms together in a molecule. So that is chemical bond. Now, we are going to discuss the causes of a chemical combination. Why the atoms combine with each other to exist in the molecular form. What is the necessity for them to combine? What makes them combine? So the first thing, the first idea is all the elements are having the tendency to attain the noble gas configuration, because noble gases are highly inert, they are non-reactive, they are highly stable, and they are having completed electronic configuration. So every other element is trying to attain that state. They want to have the electronic configuration similar to that of a noble gas, because they want to attain stability. Stability is the biggest problem with the elements. They want to be stable. So they are all trying to change their electronic configuration so that they may also have a completed electronic configuration as that of noble gases, and they want to attain the stability as the noble gases. So they have the tendency to change their configuration to be like a noble gases. This tendency of atoms of various elements to acquire stable noble gas configuration in their valence shells is responsible for the chemical combinations which are taking place among the elements. So it is a tendency, their nature. So that is, they want to have a noble gas electronic configuration, which is the stable configuration. So this is one of the two causes of chemical combination. So one of the two causes of chemical combination. What is the first cause? It is the tendency of the elements to form an electronic configuration similar to that of noble gases, because noble gases have a completed electronic configuration or stable electronic configuration. So they are stable, they do not react, they are very inert, they want to attain that inertness. So all the elements, they somehow, whether by gaining the electron or losing the electron or sharing the electron, they want to get to the electronic configuration of the noble gases. And the second reason, it is the tendency to acquire minimum energy. See, if you take the whole universe, the entire universe is tending towards minimization of a potential energy. They want to have a minimum potential energy. At the same time, they want to have a maximum entropy. These are all the two determining factors of a feasibility of a chemical process. Why a process is chemically feasible? Either that process will be tending towards a minimization of potential energy, or it may be tending towards maximization of entropy. Say, for example, suppose you are getting into a bus which is full of rush. The person who is standing will try to find a seat where he can simply sit down. And after then, if it is a long train and the travel is a lengthier one, then this fellow will try to find a place where he can lie down, because while standing, potential energy is very high. You have to give more energy to stand stably. You have to spend more energy to stand, but to sit down, less potential energy. To lie down, the least potential energy. So the system, any system in the universe will be tending towards minimization of potential energy. So when you compare the potential energy of a bonded state and an unbonded state, an atom which is in the atomic state and the same atom in the molecular state. If you compare the potential energy of the bonded state is very less, and the potential energy of the unbonded state is very high. When the potential energy is high, the system is unstable. When the potential energy is low, the system is stable. So the system is trying to attain stability by the minimization of a potential energy. So a chemical bond is formed between two atoms only if the potential energy of the system constituting two atoms decrease. See, look here, the potential energy of the atom is higher than the potential energy of the molecule itself. So what is a chemical bond? It is formed between any two atoms only if the potential energy of the system constituting the two atoms decreases. It should come down. Otherwise, the system will not form chemical bond. So these are all the two causes of chemical combination. What is the first cause? It is the tendency of an element to attain the noble gas electronic configuration. It wants to be like noble gases. And the second thing, the system wants to minimize its potential energy. So this minimization of potential energy and also the tendency to form noble gas electronic configuration, these are all the causes of chemical combination. Why atoms combine together? It is because of these two causes. The elements always want to be together. They want to be in a combined state. That is why in nature molecules are very stable than atoms. You can never find atoms as such in the molecule except a few noble elements. Even the noble natured elements are found in combined state. Say for example, nitrogen, atomic nitrogen. If you look at the atomic nitrogen, which has the half-filled electronic configuration, which is similar to that of a noble gas, but even nitrogen cannot exist as an atomic gas. Nitrogen exists as a molecular gas, N2, but helium exists as an atomic gas. So these two reasons are very important. You should understand these two reasons because only with that we can proceed further. So there are three types of bonds. One is called ionic bond, and the other one is called covalent bond, and the third one is called coordinate covalent bond. Let us discuss what is an ionic bond. See, ionic bond is formed by a complete transference of one electron or more electrons from the outer electronic configuration or outer energy shell of one atom to that of the other atom. This is the definition for ionic bond. See, both the atoms which are involving in the ionic bond formation are trying to get the noble gas electronic configuration. See, one species is losing its energy and the other species has gained the electron. So one atom has lost its electron and the other atom has gained the electron. The one which has lost becomes positively charged, which is called a cation. The other atom which has gained the electron is negatively charged, which is called an anion. Now there is an electrostatic attraction between the positive and the negative ions. And this electrostatic attraction is holding these ions together, which is called ionic bond. Now look here, this is a schematic diagram. See, this is an atom. This is an atom. These two atoms are of high potential energy. But when the first atom loses an electron, it becomes a cation. And when the second atom gains the electron and becomes an anion, these cation and anion together, now they are attracted because of the electrostatic attraction and they are existing together as a molecule. Now their potential energy is less. Moreover, the cation is having electronic configuration identical to that of noble gases, and the anion is also having electronic configuration identical to the noble gas, and and because of that also they attain stability, and because of minimization of potential energy also they attain stability, and because of their opposite charges they develop an electrostatic attraction between them. I can illustrate this with a simple example. You are all very familiar with the bond formation between the sodium and the chlorine. See, sodium is with the atomic number 11. So the electronic configuration is 1s2, 2s2, 2p6, and 3s1. So the 3s, as long as this 3s 1 electron is present, sodium cannot get the noble gas electronic configuration. Suppose if this wants to get a noble gas electronic configuration, either this 1 electron should not be there or 7 more electrons should be there. Now the system takes a decision whether to lose the 1 electron or to gain 7 more electrons. See, look here. If it loses 1 electron, the atomic number becomes, the electron number becomes 10. So the electronic configuration becomes 1s2, 2s2, and 2p6, which is similar to that of the neon electronic configuration, which is a noble gas. Suppose if it gains 7 more electron, it will become 3s2 and 3p6, which will be the noble gas electronic configuration of that of argon. Now the sodium has to decide which one is easier, either to lose 1 electron or to gain 7 more electrons. So the sodium, it takes a route, which is very simple, to lose the 1 electron. So the 1 electron is lost in the first reaction. So sodium 11 now becomes sodium with a 10 electron, and it becomes a sodium plus because 1 electron is lost. And now the electronic configuration is 1s2, 2s2, 2p6, which is the electronic configuration of neon. So it attains the stable electronic configuration by losing 1 electron. But this last 1 electron, it gets transferred to the chlorine atom, because the very definition of the ionic bond